Okay, what we're going to do today is we're going to solve equations via matrices. Alright, starting off, let's look at this problem here, 2x equals 14. Normally people would just divide by 2 and you get x equals 7. That's typically how you would normally solve this. But there should be another alternative way of solving this, and that's by multiplying by the reciprocal. Okay? These cancel out to 1, you get x equals 7. Same format, but now we're multiplying instead of dividing. We're going to take that same concept and we're going to apply it to this problem here. Now, in this problem here, you've got to realize that there are some things that you need to be aware of. And those are these numbers here. These are our coefficients. And what we're going to do, not the y, but the number 1 in front of it, actually. What we're going to do is we're going to take those coefficients and we're going to plug them in right here. So 4, 3, 3, negative 1. This is called my coefficient matrix. Alright, this is my coefficient matrix. Then what we're going to do is we're going to take our variables. Now our variables are x and y. And we're going to put them in this order, vertically, x and y. This right here is my variable matrix. Variable matrix. And then finally, we take our two numbers at the end, which are negative 4 and negative 3, and put them at the end. This is called my constant. Constant matrix. Okay? Altogether, this is a matrix equation. All right? Altogether, this is a matrix. You can't see that. This is called a matrix equation. Matrix equation. Okay? Now, remember in solving, we multiplied by the reciprocal. So what I'm going to do is I'm going to put this right here in my calculator. All right? Now, once I put in my calculator under matrices, it's a 2 by 2. I'm going to put this as matrix A. I'm going to put this as matrix A. Let me go ahead and erase this. All right? So again, you have to define these in your calculator. All right? This is going to be matrix A, and I want this to be matrix B. All right? There's a reason for that. Now what you're going to do is you're going to put matrix A right here. You're going to bring down your coefficient matrix, and then you're going to bring down your matrix B. Now in order to fill in the blank here, in order to solve the equation, this we're going to multiply by the inverse. All right? We're going to multiply by the inverse, and notice the inverse has to come first. So in this case, if I find the inverse of matrix A, it turns out to be 1 over 13, 3 over 13, 3 over 13, and negative 4 over 13. And that's what I'm going to put over here. So again, 1 over 13, 3 over 13, 3 over 13, and negative 4 over 13. Now, what this is basically is you're simply doing this. You're simply taking A and multiplying by the inverse. Over here, you're taking B and multiplying by the inverse. And what that ends up giving you is x, y, and the answer would be negative 1, 0. So that's a coordinate point. So negative 1, 0 would be your answer. Okay, let's go to the next one. We're going to use the same concept on this one. All right, so I want my matrices. I want my coefficient matrices, which are 7, negative 5, 6, and 5. Okay? Again, those right there are my coefficients. Let me see if I can get a better one. That's my coefficients right there. Oh, that doesn't look too good. All right. So, coefficients. We're going to multiply that by xy, and we're going to put it equal to our constant matrix, which is 61 and negative 22. Okay? In the calculator, you have to name this as A, and this is B. And when you solve it, you have A, x equals B, just like any equation. In order to, normally we would divide by A, but in this case, like we did in the very first problem, we want to multiply by the reciprocal. So I'm going to multiply by the reciprocal. Now notice that came first. Order is very specific. So we're going to multiply, same thing here. These two cancel out to 1x equals. And then whenever you do the inverse of A times B, you will get 3. Now this, remember, this is your your variable matrix of x, y. You're going to get the answer of 3, negative 8. And so that would be 3, negative 8 as your answer. Okay? Next problem. Same problem, except this one has, this is a 3 by 3. Now in this 3 by 3, I'm going to do the same matrices. 3, 2, negative 1. 2, negative 1, 2. 1, 3, negative 1. Now notice, those are all these leading coefficients. Okay? In this case, I have x, y, and z, and then my constants are 11, negative 3, and 8. All right, so now, right here, 3, 2, negative 1, 2, negative 1, 2, 1, 3, negative 1, x, y, z, and again 11, negative 3, 8. Now, this right here is going to be my inverse. So this will be my inverse times my matrix. This is going to be my inverse times matrix B. So when I plug that in, I get x, y, z, and when I multiply these two together, the inverse of A times B, I end up getting the answer of 2, 1, 1, negative 3. Okay? That's with a 3 by 3 matrices. Now if we were to do it on our own, we would do again, here's our leading coefficients, so negative 3, negative 1, 4, 6. Now, if you notice, there is no y. So we're going to put a 0 in its place, and then negative 1 for z. 1, negative 2, 3. All right, so that's going to go in matrix A. We are dealing with x, y, z. And then our constants are 11, negative 9, 0. So again, this is going to be matrix A. This is our x, y, z equals matrix B. Now, we're going to multiply by the inverse. Multiply by the inverse. That cancels out, and you're left with x, y, z equals negative 1, 4, 3.